For recording number 5, we have to talk about the next part of the game called the glucostatic theory that kind of maps to some of this glucose idea as well. Your book on 357 kind of talks about this. The basic idea here is that going to this idea of glucose utilization, it seems the hypothalamus does a good job of monitoring glucose levels, that when glucose levels are too low, that it'll stimulate the release of glucagon, and then you'll get more readily available glucose to be used. And when glucose levels are high, it'll secrete insulin, or lead to the secretion eventually of insulin. So the hypothalamus seems to be the key part that kind of regulates this glucose. The idea that glucose is supposed to be maintained in a static way by your body is called the glucostatic theory, page 357. And research has actually shown that if you take an animal that is actually very, very hungry, glucose levels are very low, that if you actually put just a dab of glucose up in the hypothalamus in the right spot, it won't eat, as if the hypothalamus is kind of monitoring the amount of glucose level. You can almost fool it in a way by putting a tiny bit of glucose up there. So the idea of metabolism and glucostatic theory is certainly consistent with what we know as far as the body and how it uses things. The next important idea is kind of the idea, and it's more psychologically based, of lipostatic theory. The idea of lipostatic theory is that, once again, your body tries to maintain a sufficient amount of energy, and it does this not by monitoring glucose, but by monitoring the amount of lipids, fats per se. And researchers a long time ago, and your book goes into some detail here, found that this lipostatic idea, I think the idea was by Kesey in the 50s or 60s, Keesy, had some validity to it. They did some very simple studies here. What they did in one particular study with a rat, they went into the rat in a particular area of the hypothalamus, the side of the hypothalamus called the lateral hypothalamus. They went in and they stimulated, in rats that were food deprived, they stimulated the lateral hypothalamus. And they found that when you stimulate the lateral hypothalamus, that the organism wanted to start eating. The organism wanted to start eating. On the other hand, if you went into the lateral hypothalamus and destroyed this area, it seemed the organism would never want to start eating. It would actually starve itself to death. So this lateral hypothalamus in the early theories ended up being quite important. And it was actually called the hunger center, was the name. The hunger center, named after what happens when you stimulate it. It seems that when the lateral hypothalamus is stimulated electrically or otherwise, this gets an organism to start eating. So the lateral hypothalamus, kind of the idea of a eating center per se. This is the area that will start you to get you to eat more, the lateral hypothalamus. Then they did another interesting set of studies, and your book has some details on this, where instead of doing the lateral hypothalamus, they went to another area of the hypothalamus, the ventromedial, kind of in the middle on the belly of the hypothalamus, and they did the same thing there. In the first situation, they stimulated the lateral hypothalamus, and when they stimulated the lateral hypothalamus, sorry about that, I had to put a little pause on the tape, so let me start again with the second part. We just covered the lateral hypothalamus. The second part of the equation, and this is documented actually on page 365 and 366 of your book, is the ventromedial hypothalamus. Very interesting what happens when you stimulate this area. With the ventromedial hypothalamus, when you stimulate this area, it seems to signal to an organism, stop eating. Stop eating. And so it's often called the satiety center. When this area gets stimulated electrically, the organism would stop eating. So this was called the satiety center, not the hunger center like the lateral, but the satiety center. On the other hand, something very interesting happened when you destroyed the ventromedial hypothalamus with a lesion. What seemed to happen here is the organism, the rat in this case, would eat and eat and eat and eat. And according to theory, the idea was it would kind of destroy this signal to stop eating. And what the book argues, and the researchers argued as well, is that it was as if the organism was forming a new high set point. The idea that the set point was just much higher here, and the organism became very, very obese because of the destruction of this area. So this information and the information I'm sharing with you really led to the idea that maybe there are eating and feeding centers in the brain. The idea that eating and being full is controlled by key areas of the brain. And that's the idea behind the lipostatic theory per se. What's been very interesting in future research with the idea of the ventral medial hypothalamus, they find that when the organism had this area destroyed, yes, it would form a new set point, but it wouldn't just eat anything. It would actually be very finicky about what it would eat, and then if it found something it really liked, it would binge. That's exactly what would happen to the organism. So the idea started off with the idea of centers here, the lateral hypothalamus and the ventral medial as feeding and eating centers here. Now, the truth of the matter is there seems to be a lot of other structures involved here. Eating is not so simple as just saying it's this structure or that structure. There are a lot of structures that are involved in eating, even at this level of the nature of things. So researchers have become very, very interested in this whole end, because the idea is if we can figure out what structure or what neurotransmitter has gone astray, then maybe what we can do is kind of that type reductionist idea of just find that neurotransmitter, fix that neurotransmitter, and then fix eating behavior. And on the next part, Roman numeral 3, I kind of share some of that information. It's the idea of the magic pill. And a lot of your posts were actually based on this, the idea of Topamax actually as one product that could be used. Topamax, as it turns out, is, as a few of you actually said, is actually a product that works by, it's usually given for people that have epilepsy, seizures, and even migraines, that it's actually a GABA agonist. It helps GABA bind better and will actually stop epileptic seizures, as the case may be. I know this, my daughter actually has epilepsy. And one of the side effects actually of Topamax is it tends to get people to lose weight. But it will not be a magic pill so much, because it's actually a very significant product that's given for epilepsy, seizures, migraines, and other things. So this is actually a receptor side effect that seems to help some people out for eating per se, but it's not going to be kind of the new wonder drug per se. So what I would like you to actually do, and I think I posted this in the information, you're going to have a little extra homework here per se when you go and I want you to go to the clinical trial spot and see if you can find anything with Topamax where it's being used and kind of describe the nature of the study as far as what Topamax is being used for. So you do that extra. A few other substances have come across the radar as well. One of those substances is, and actually your book talks about kind of the precursor of this, there was something called fen-phen about 15, 20 years ago. Serotonin agonist. It was understood that when you actually had these satiety signals being sent by the ventral medial hypothalamus, that it seemed serotonin would be released. So one of the ideas was, well, maybe we can increase serotonin levels and give a serotonin agonist. That's where fen-phen came from. But the problem is you gave that and it didn't necessarily help, and there were a lot of side effects to doing it. Now one of the products that they're still experimenting with that is something called Belvig. And I put a little description down below. It's actually a receptor agonist, seems to help out with appetite. See if you can do a little Google search on that one as well. Not Google search, but clinical trials. Go to the clinical trials and type in, what is it? Lorcaserin. I didn't say that at all right. Anyway, look up Belvig and see if you can find a study that kind of covers that. Finally, last but not least, there are a number of other substances as well that have been implicated in eating behavior. Neuropeptide Y being one, leptin being another one, cholecystokinin, and even gremlin. What I'd like you to do is I put a little title of an article there that's in a clinical trial. See if you can do a little digging on this and just figure out the main idea. The idea for all of these products is this idea of a magic bullet. Can we actually just have a substance that we can just take that can stop the obesity epidemic that's going on in this country and fix the neurobiological problem? So see if you can do a little digging on this, add that to your summary, and hopefully this will make good sense. Thanks. Bye.